Hi viewers, myself Amarendra Reddy from Electrical and Electronics Engineering Department. Here I am going to cover some questions which covers what different kind of concepts in circuit theory or even network theory, right? That is our electrical circuit, and especially towards the what AEE exam which is going to conduct on Jan 22nd. Right, exclusively questions we are taking to match the what standard of this exam, right. So that it is like what revision for all these topics, okay, right. Whoever preparing for these exam means especially for AEE aspirants from what electrical stream, right. So here we will see some questions so that we can cover the what different concepts in this circuit theory format, right. So we will see one by one here. Now move on to first question here, what they given. Observe the question here from the what circuit. So in the circuit shown, which of the following statement is not correct? As we already mentioned, you need to be very clear, okay, right, whether given question they are asking for what correct statement or what not correct statement. So that we need to focus here, okay. So if you observe here for the given circuit seems to be what they indicated what mesh here, two mesh, okay. This is first mesh and this is what second mesh, and again in between the what two mesh, whenever we have a what current source that deals with what we call super mesh, okay. So whenever we have the what current source between the what two mesh, we call that as what super mesh. What is the reason? When we have current source, voltage across the current source could be any value which we don't know in advance. That is the reason why we consider this as what super mesh. Means super mesh means without going with this super mesh. Suppose you are trying to solve this circuit by the what normal mesh analysis. What we do, general case, we write the what KVL here. When you write the KVL, what we do, this is the what polarity for this and this is the what polarity for these resistances based on the what current direction, right. So when current is entering into this negative terminal minus 20 plus 6 into I1, but what we write for this means voltage across this current source could be any value which we cannot say in advance. Means after finding all other branch voltage, then you can find that voltage, but in advance we cannot predict. That is the problem with the what condition. Due to that reason only we are naming this as what super mesh. Super mesh analysis is the what combination of mesh analysis, means it is a combination of what we are saying KVL plus Ohm's law. Super mesh analysis means it is the combination of KVL plus KCL plus Ohm's law also we represent, right. Now how we are going to solve with the super mesh analysis, we will see here, so that we can predict or we can identify what is the correct statement and what is the not correct one. KVL means how we write. Before going with the KVL, KCL how we take, look at that. If I select this node, right, if I select this node, what is happening here? This is the current direction what I1 and this is what current direction what I2, and 6 amperes is already indicated in the upward direction. When I write KCL here, KCL if I write for this node, okay, incoming current is what I2. So incoming current we place it with what minus sign, okay, incoming current is indicated with what minus sign here, and again outgoing currents are what 6 amperes as well as what I1, both are what outgoing currents. Now if you check with that, what you can comment here, I2 which is equal to 6 plus I1, this is the what KCL for this node. So we got this, and then we already mentioned that this circuit has a what super mesh, and if you check with the KCL also, this equation is also satisfied. Now how we write the what KVL for super mesh. KVL for super mesh means, how we are going to write KVL for super mesh? Whatever the branch voltage associated with both mesh, we write in what? One equation. Now we consider this as what? Super mesh, means by considering this, and we won't count this branch. Okay, if you follow with that, what will be the expression? Minus 20 plus here 6I1, means these are the two branches associated with what? First mesh. And what are the other two branches? 10 and 4 you can take individual also. 10 I2 plus 4 I2 is equal to 0. Now simplify this, what we get? Minus 20 plus 6 I1, and this one is what? 14 I2 we will get, which is equal to 0. Check with that equation where it is there. Yes, it is also present in this, and automatically if you see the last option, minus 20 plus 6 I1 plus 2 into I1 minus I2 is the what? Not the correct statement. This one is not correct. It is not matching with the given circuit. First three are valid, and you can solve even this circuit by using these two equations. So here which one is not correct means fourth option is not correct according to the what? Given circuit, because it is associated with super mesh, right? Mesh analysis means what we are saying? Mesh analysis means it is only combination of what? KVL plus Ohm's law. But super mesh means additional to that we are even having what? KCL. That is the thing. Got the point? Always if you want to have a solution, number of equations must be equal to what? Number of unknowns. Based on that we are going with these equations, right? Super mesh, when you apply the KVL, we will get one equation. KCL, when you write for that, we will get another equation. That is the way we need to answer such questions. Anyway, next move on to the another question here. Okay, so what we have here? Here question is about what? Finding the time constant for the network shown in figure. So look at here. First of all, when we have RC circuit means what must be the time constant here? Time constant tau is equal to R into C, means whenever multiple elements means we take it as what? R equivalent and C equivalent. Whenever we have RL circuit means what must be the time constant here? We take it as what? L by R. Multiple element means L equivalent by R equivalent. These are the relations we use to find the what? Time constant. Now if you follow with that, so when you close the word switch here, how the connection seems to be? R and 2R connected like this, okay, and this is what? Our capacitance, right or not? This is what? 2R, and this one is what? R. Now here in between these two, right or not? Here in between these two means terminals, we can separate the what? R as well as what? C. Means if you follow with that concept, what we get here means what is the R equivalent here? Both are connected in what? How? If you look at this A and B terminals, suppose you are separating and you are observing from what? A and B terminals. How these are connected? R and 2R both are connected in what? Parallel. Parallel means how we write? R into 2R by R plus 2R. Simplify for this. So we get what? 1R will get cancelled. We get result 2R by 3. This is what? R equivalent. Understood? Now if you go with C equivalent, we have only one capacitance, so C equivalent is equal to only C we will get. Now substitute in the relation what we have. R equivalent is how much here? 2R by 3, and C equivalent is what? C. So how we write? 2RC by 3 is the what? Time constant, which is in seconds. So which one is matching with our result here? 2RC by 3 is the what? Time constant for this what? Circuit. Okay. Now move on to the next question here. What we have? the current I in the circuit which is indicated. If you follow with that mesh analysis here, because they are already indicated mesh, right. So, you can answer this in what, two ways. Mesh if you go, what will happen? Mesh analysis if you do, right. Mesh analysis if I take, this must be the what, polarity, right. This is the polarity according to the what, current direction, and already current direction, and this must be the what, polarity according to the what, second one. So, what we get here, anyway, if you write here, this is the what, polarity for this minus 10 plus 2 I1 plus 5 into both I1 I2 are entering into this, right. Definitely this must be the what, current I1 I2 both are entering, right. And again, what is the problem with this? If I write mesh analysis, what will be the voltage? We don't know. Okay, that is the difficulty. Instead of that, what we do here, we follow with what, nodal analysis. Okay. Anyway, second mesh current is definitely, it must be what, 5 amperes only, but still nodal if you take, because mesh will not work for this kind of circuit based on the connection. Okay. So, it is not suitable. Okay. What we do here, if you follow with the nodal method, I am assuming this as a reference node and this one is what, principal node voltage is V. I am assuming all the currents are away from this, and this is what, anyway, incoming current. If you follow with that, what we get, V minus 10 by its resistance is 2. Next, V minus 0 by its resistance is what, 5, and this one is what, incoming current. So, minus 5 we will take. This is what equation. When you are able to find that node voltage, automatically you can find current through that 5 ohm. Simplify this, what we get, if you take LCM 1 by 2 plus 1 by 5, so which is equal to what we get here, 5 if you take into right hand side plus 5 plus 10 by 2 means again 5 only, 5 plus 5 10. If you take LCM, what we get, 7V by 10 is equal to 5 plus 5 10. So, V is equal to 100 by 7. So, node voltage we got it as what, 100 by 7 volts. After having this node voltage, what is the current flowing through that 5 ohm resistance? 100 by 7 minus 0 by its branch resistance is what, 5. So, if you simplify this, what will be the current flowing through that 5 ohm? So, 100 by 7 by 5 means we get result 20 by 7 amperes. This is the what, correct option. Anyway, we have this result. So, current flowing through this. Okay, most of the time nodal method is best, but sometimes don't fall under this trap. Okay, when mesh is there, so we have to, means when they indicate the word current direction, so we feel that okay, mesh we have to apply, but most of the time we need to check what, whether it is mesh or nodal method, where we have less number of equations, right. So, whenever we have less number of equation, automatically we get answer in what, short time. That is the strategy you need to follow here. Got the point? Now, move on to the what, the next question here. The current I indicated in the what, network shown below is what? Okay, this current, okay, and with this direction only is asking what is that current. Look at here, I am assuming this as what, reference node voltage is 0 and this node voltage is what, V. So, now by nodal method, if I follow with that, look at here, by KCL at that node, right. So, I am assuming all are what, outgoing current, this one also I am assuming outgoing, and here already outgoing current is given. So, 2 plus what we get here, V minus 4 by, okay, V minus 4 here voltage source by what is the resistance here, 2 ohms, and here what is the current, current flowing from V to 3 VR we are assuming. So, V minus 3 VR by branch resistance is what, 5. This is what, one equation, right or not, if you write the word KCL. And again if you assume, means not assume, they already given this is the kind of direction, I is entering here and 2 amperes is flowing. So, what must be the current here by KCL? By KCL, what is the current here? it must be what I is entering, and this one is 2, means it must be what I minus 2 amperes which is flowing through this branch. But what is that current? This node voltage V minus 4 by its branch resistance is what 2. So this is what second equation. Now solve these two equations, automatically we can find the what current, because current only we need to evaluate. If you simplify these two equations, what will be the result we get? Minus 6 amperes we get. Okay, minus 6 amperes is the what? Correct answer for this, right or not? If you solve these two equations, this must be the what right answer. Understood? So just follow with that circuit how they connected, and according to the given direction, this must be the what answer. Move on to the next question here. What they indicated here also, they are asking to find what current through this what 10 ohm resistance. Then how to find this without any hesitation? Okay, right? If you follow with here nodal method, what will happen? V1 and here what V2 we will get, or here it is V2 because he considered this as what reference, then it becomes what V2. But anyway, right? Anyway, what will happen here? What will happen to this if I consider reference node? It becomes what 2 nodes, 2 equations will come. Instead of that, we convert this into what source transformation. Okay, nodal method means we get 2 equations. In that way you should not think, because 2 equations you have to solve 2, then 2 node voltages will come, then difference. Okay, that is time taking. Instead of that, you convert this into what voltage source. Here also you convert into voltage source. What will happen? I can convert the current source in parallel with resistance with what voltage source. So how much we get? 2 into 5, that is 10 volts, and the direction is upwards, so polarity will get, and that 5 ohms comes in what series, and already 10 ohms is there, will not be disturbing this, and this must be the what current direction. And here if you see this 2 ohms is in what parallel with 4 amperes, so I can even convert that into a what voltage source with this what polarity, because okay, how much we get? 2 into 4 means 8 volts, and 2 ohms is in series with that. So now the rest of the thing is to just apply the what KVL here. So this is the what polarity based on the current direction, because they only given the current direction. Now if you write the what KVL for this, what we get? KVL. So current entering into this negative terminal, that is minus 10 plus 5I plus 10I plus 2I, and this one is what plus 8 is equal to 0. Simplify here. So 5 plus 10, 15 plus 2, 17, I is equal to how much we get? 8 minus 10 minus 2, if you take the other side plus 2. So I is equal to 2 by 17 amperes, but in options it is in other way. What is that? If you simplify further, we get 0.117 something, that is what 0.118 amperes. So whichever the form, whether it is 2 by 17 or 0.118, this must be the what right option. Just we did what source transformation. Okay, by source transformation, understood? Here instead of nodal method, if you follow with source transformation, it is easy for us. Got the point? Next, move on to the another question here. A system is what linear if and only if satisfy the what? Linear means it should satisfy the what? Linear system or linear network should satisfy the what? Superposition principle. Actually, superposition principle consists of homogeneity rule. Understood? Homogeneity rule as well as what additive rule. But here in the options, if you see, Principle of superposition and principle of homogeneity only they given. So, you have to select what? Both. Whenever both are satisfied, okay, then particular network or system, definitely what? It is a linear network. So, based on the options we have to choose what? Third option here. Now, move on to this next question. He is asking what? Norton's resistance of the circuit shown in what? Figure. Whether it is Thevenin's resistance or Norton's resistance, procedure is what? Same. What we do? We have to deactivate the what? Sources present in the what? Network. How to deactivate? We have to short circuit the what? Voltage source, and we have to open circuit. When you do this activity, how it seems to be? How the network we will get 4 ohms, and this one is what? 12 ohms, right? So, both seems to be how these are connected. If I make it short circuit, like parallel combination. Now, we need to open circuit the what? Current source. Already 1 ohm is present here, and from these terminals only we are finding the what? Thevenin's resistance or what? Norton's resistance. As I said, procedure is common for finding Thevenin's resistance or what? Norton's resistance. We need to deactivate the what? Sources. Deactivation means we should short circuit the voltage source and we should open circuit the what? Current source. Understood? So, when you do that, when you observe from these terminals how these are connected, 4 and 12 connected in what? Parallel, and equivalent is in what? Series with what? 1. So, if you simplify this, 4 into 12 by 4 plus 12, so plus 1. So, if you simplify 48 by 16 means 3 plus 1 means what will be the result? Norton's resistance is how much here? 4 ohms. So, what is the right option here? Third option seems to be what? Matching with our result. Understood? Okay, this is the way we need to identify the what? Norton's resistance. Look into the next question here, and this time we have question related to like a basic concept, okay, right? How to find the power here. Alternating voltage is given, okay, voltage is given with what? A plus JB like this, okay, and the current is given as what? How the current is given? C plus ZD is given. Now, the power in watts is given by, okay, right? If you look at that, power is the what? S is equal to VI complex conjugate, VI conjugate or IV conjugate. But here if you go with complex power, S is equal to V is given as what? A plus JB, and complex conjugate of current if I take, I will get what? C plus ZD complex conjugate is how much we get? A plus JB into C minus ZD we will get. This is the complex conjugate for that. Now, if you go with the multiplication, what we get? AC minus JAD plus JBC. J square means minus 1, minus of minus becomes plus BD. Now, separate real and imaginary part here. AC plus BD is the what? Real part. Okay. J if you take common, what we get? BC minus AD means this is the what? Complex power. Okay. S is equal to P plus J cube. P is in what? Active power. It is in what? Watts. Q is a what? Reactive power. Units are in what? Volt ampere reactive. Now, the question is what? Power in watts is given by which one? You correlate that. Real part is what? Watts means AC plus BD is the what? Active power, which is in what? Watts. Okay. And if you see that reactive power, what is the result? BC minus AD is the what? Reactive power. This is what? Volt ampere reactive. But question is about to finding the active power. So, we have to take that option. So, AC plus BD where we have, this one is our, so that is the right answer. BC minus AD is also present, but this is valid only when we have reactive power. Understood how you are finding powers in this case? Now move on to the next question. Okay, to have some more different kind of concept. What is the question here? Here also question is related to Norton's resistance between the terminals A and B of the given circuit. Look at here, we already mentioned, okay, A and B terminals means here is asking Thevenin's resistance or Norton's resistance. Procedure is same for Thevenin's or Norton's resistance. What we do? We deactivate the current source by open circuit, and we deactivate the voltage source by short circuit. Here current source is given, you have to make it open circuit. If you draw here open circuit and observe the remaining components as it is, okay, this must be the kind of thing, okay, and here in this branch we have these two elements, right? But here in between A and B terminals we want R Norton's or R Thevenin's, right? So if you observe here 10 ohms and this is 20 ohms, 40 ohms, okay, 80 ohms, right? Here it is open. Now if you stretch these terminals, how the connection seems to be? This is A, and what kind of connection is there? This is one branch and this is another branch, right or not? So one branch, if you see that upper one and the lower one, how the connection is there in between A and B terminals? Upper one is 10 and 20 both are connected in series, means 30 ohms, and here 80 and 40 both are connected in series 120. Now both are connected in parallel. So how much we get? 120 is in parallel with 30, right? So 120 into 30 by 120 plus 30 means 150. So how much we get? 30 means 5 times. 5 into how much we get? Result will be 24 times. Okay, 24 ohms is the Norton's resistance. Where it is matching? Fourth option is our right answer. Okay, right? Understood? You have to be careful where the sources are present and how to deactivate the sources. Current source must be open circuit and voltage source must be short circuit further. Now move on to the next question here. Here the question is related to maximum power transfer. The source impedance is 6 plus J8. Here this one is 6 plus J8, and maximum real power is transferred from source to load. Okay, means whenever ZL is variable, what is the condition in maximum power transfer theorem? When load impedance is equal to complex conjugate of source impedance, right? Means 6 plus J8 complex conjugate is how much here? 6 minus J8 is the load impedance when okay, maximum power is transferred from source to load. But in the option the typing mistake is there. Okay, this is 6 minus J8. Okay, last option is 6 minus J8. So this is our right answer. Okay, so it is one of the condition in maximum power transfer theorem. So where ZL consists of RL plus JXL. Whenever both are variable elements, what is the condition here? Load impedance is equal to complex conjugate of source impedance, means RL is equal to RS, and whereas XL is equal to, we get minus XS. That is the reason why we mentioned it as complex conjugate of source impedance. Understood? So some questions we observed here through these different kind of concepts, right? Means this is a kind of like revision useful for you for these kind of exams. Like this only we can expect in our upcoming exam, that is on 22nd January, that is for electrical AEE stream. Okay, so please utilize this opportunity, right, and try to get the success in this exam. Okay, all the best for your exam.